Hello guys, today is another day and we are going to learn about how to determine chemical formulas. So there are two types of chemical formulas, which one is the empirical formula and the other one is the molecular formula. One may ask, what is empirical formula? Empirical formula is the simplest formula of a compound which expresses the ratio of a number of different atoms present in a molecule. And also the molecular formula is the formula of a compound which expresses the actual number of each kind of atom present in a molecule. Let's continue. So let's start. Determination of chemical formula. There are two types of chemical formula, namely the empirical formula and the molecular formula. Empirical formula. So we are starting with the empirical formula first. It is the simplest formula of a compound which expresses the ratio of number of different atoms present in a molecule. And also the molecular formula, and which is the second one we are about to look at. It is the formula of a compound which expresses the actual number of each kind of atom present in a molecule. So take note, sometimes the molecular formula and the empirical formula may be the same. So don't be confused with that. The steps in determining the empirical formula. 1. Determine the various elements that make the compound. Always these elements will be given in the question. 2. Determine experimentally the mass percent or the mass of the various elements present. Use the data to calculate the empirical formula. So note these numbers. So whenever you get a ratio of 1:1.5, you multiply through by 2. Whenever you get a ratio of 1:2.4, you multiply by 5. And when you get 1:1.33, you multiply by 3. And also 1.66, you multiply by 3. Let's move on. So sample questions that we are about to try our hands on in order for you to understand how we go about with the empirical formula and the molecular formula. The question says that an organic liquid A was found to contain 60% carbon and 13.3% hydrogen. The third component was assumed to be oxygen. Calculate the empirical formula. So we are told to calculate the empirical formula, but we were not given the mass percent of oxygen. So we know that the total percent, which is 100, minus the mass percent of the other ones, which is 60 plus 13.3, which we are getting 26.7. So this is the way that you solve it. So you write the symbols for the atoms. After that, you write their masses percent and their mass percent divided by atomic mass. So carbon, which is 60, divided by its atomic mass of 12, and hydrogen 13.3 divided by 1, and oxygen 26.7 divided by 16. So when we calculated, we had 5, 13.3, 1.67. So dividing through by the smallest number. And obviously you can see that 1.67 is the smallest. So you divide by 1.67. 5 divided by 1.67, 13.3 divided by 1.67, 1.67 divided by 1.67. So we had our answer to be 3:8:1. So this ratio will determine the number of atoms present in it. So from this ratio, you can say that carbon is 3, hydrogen is 8, and oxygen is 1. So therefore, the empirical formula is equal to C3H8O1. But it's not necessary to write the 1. So follow these procedures used by me to find your own ones. At the end of this video, I'll be giving you questions to try on your own. So take note of this when determining the molecular formula. The knowledge of molar mass and relative molecular mass of a compound in which the empirical formula has already been determined. The molecular formula can be also worked out. So use this formula to work out the molecular mass. So the molar mass of the compound is equal to the empirical formula in the bracket and the integer that you multiply through. So where the molar mass of the compound and the one in the bracket is the empirical formula of the compound, and the n is any positive integer to be determined when you calculate. So question 2. 20 grams of a compound containing C, H, and O are found to contain 8 grams of carbon and 1.33 grams of hydrogen. Calculate the empirical formula of the compound and hence its molecular formula when the relative molecular mass is given as 60. So these are the atomic mass of the atoms. Carbon to be 12, hydrogen to be 1, oxygen to be 16. So mass of oxygen is equal to 20 minus 8 plus 1.33, and which we had an answer to be 10.67 grams. So the mass of oxygen is 10.67 grams. So carbon, hydrogen, and oxygen, so their masses, that's 8, 1.33, 10.67. So dividing by their atomic mass, 8 divided by 12, 1.33 divided by 1, and 10.67 divided by 16, which we calculated and had 0.67, 1.33, 1.67. So dividing by the smallest, which you can see is 0.67. So 0.67 divided by 0.67, 1.33 divided by 1.67, 0.67 divided by 0.67. So we had 1 is to 1.9 is to 1. So you approximate the 1.9 to 2. So 1 is to 2 is to 1. So the empirical formula is CH2O. Since the relative molecular mass of the compound is 60, so we are going to use that to determine the molecular formula of the compound. So it maps that from the original formula, M is equal to the empirical formula times the integer. So the molar mass of the compound is 60, which is equal to 12 plus 1 times 2 plus 16. And we add 30 and is equal to 60, n is 2. So the molecular formula, which is the empirical formula times 2, which we had an answer to be C2H4O2. So this is the molecular formula of the compound. You can see that they are not the same, but sometimes you may get the same values as the molecular and the empirical. This is the end of the video, and these are the questions that you have to try. If you have any difficulty in solving this question, just comment in my comment section below and I'll address that issue to you. Thank you for watching. Bye. So don't forget to like and subscribe for more videos upcoming. Bye bye.